All right, I'll go ahead and get started. Can everybody hear me okay? Perfect. Good turnout. Lots of people loving Stormwater here. Hey everybody, my name is Connor Badgett. I'm a GIS analyst with GeoDecisions, accompanied by Gannett Fleming Trans Systems. I've been an embedded contractor with the NCDOT for almost 2 years. I've worked on hydraulics projects to map and process, Hurricane Helene data. I've worked on the Atlas project under the Environmental Analysis Unit. And today I'm going to be talking about stormwater. So we assisted and are currently assisting the NCDOT, the Department of Transportation, with a stormwater project to basically map stormwater infrastructure within the NCDOT right-of-way for the renewal of a stormwater permit. We're doing this in conjunction with AECOM. GeoDecisions is taking more of the technical portion, the GIS portion, and then AECOM's taking like the program management section. So let's get into it. So first I'm going to talk about some of the background of the NPDES permit requirements, what the new requirements are, and then our phase 1 goals for this project. So NCDOT has held a National Pollutant Discharge Elimination System stormwater permit since 1998, and that allows for the drainage of stormwater from the NCDOT right-of-way. So under that permit, the DOT is required to plan, implement, assess, and report on compliance with the reduction of pollutants in stormwater for their right-of-ways. So in 2021, the NCDEQ implemented new mapping requirements. So essentially saying that, hey, NCDOT, you have to map your stormwater infrastructure within your right-of-way. So in phase 1, we were tasked with basically conducting stormwater inventory mapping for 6 NPDES phase 1 communities in North Carolina. Those are the municipal separate stormwater sewer systems. And there are 6 of those, and that is the largest municipalities in the state: Fayetteville, Raleigh, Greensboro, Charlotte, Winston-Salem, and Durham. Next slide. So separately from the NCDOT permit, the MS4 communities are required to map their own stormwater infrastructure. So they already have these data sets, right, under their separate NPDES permits. And the NCDOT, for this phase of the permit, is only required to map stormwater infrastructure within their right-of-way for those communities. So we decided, along with permission from the NCDEQ, that we can basically aggregate the separate data sets that those municipalities have into one data set within the NCDOT right-of-way. So basically, to summarize, this is a data aggregation project to take all of that separate municipal data and combine it into one data set to fulfill the requirements of that NPDES permit. So here's our phase 1 goals. I'm really just going to be talking about task 4 there, the creation of a stormwater database to serve as a comprehensive authoritative data set for stormwater data for the NCDOT. This includes like the creation of a database schema, the aggregation of that data, field mapping of the separate municipality data into one schema, and then we're also including NCDOT data in that database. So now I'm going to talk about some of the process, how we came up with the database schema, how we got that different data into our data set, and then what products we delivered. So we received databases containing different feature classes and lots of different schemas, right? Some people would have pipes as one data set, separated out from culverts. Some people or municipalities had those combined into one data set. So from looking at all of those data sets as well as the existing NCDOT data sets, we came up with a database schema with 3 feature classes. So that is open conveyances and surface waters, pipes and culverts, and then assets. So open conveyances and surface waters were combined because, number one, surface waters can also act as stormwater conveyances, as well as sometimes the municipalities didn't differentiate between an open conveyance and a stream or a surface water. Much the same for those pipes and culverts. And then assets is our point feature class, and that is basically just anything that existed as points, right? Manholes, inlets, outlets, things like that. So I think that's the next slide. So now that we had our schema, we needed to, or our database schema, we needed to kind of field map everything into a common schema. So that was a lot of the work on this project, was kind of looking at each field within each data set, looking at sample values, and then using also the NPDES requirements, coming up with a schema for each feature class, right? And then, so we took all of that data, we looked at all of that data, and then basically just mapped that into the destination feature class schema. And we did this initially just kind of in Excel so that the client could see how we're mapping these things together, what attributes we're pulling, and actually also where we're missing data. You see several of those rows or columns are missing data. But we tried to make sure it was a schema that could be readily populated without a bunch of null values. And then to actually do this work, we used FME, or Feature Manipulation Engine. And this was also just used as it's a good visual way to see what's happening to each data set, right? Do you need to do any other projections? Do we need to extract coordinates from our data sets to populate, X, Y locations? And then we also have our attribute managers there that are, plugging that into essentially the destination schema. And then here's our products delivered. I didn't do the entire state because that was just so much data. We had millions and millions of lines and features. This is just a sample. So the green dots are assets, blue lines are our open conveyances and streams, and then pink lines are the pipes. So now that I've shown you some of the products, I want to talk about some of the challenges that we faced during this process. So you see there a lack of right-of-way data, how do we identify outfalls, and then which hydrography data set should we use to map outfalls, which I'll touch on more in a second. So currently the NCDOT lacks a comprehensive right-of-way layer. I know DIT is working on that, but it's not available yet. And remember, this project is only for assets within the NCDOT right-of-way. So we thought we needed to make a right-of-way estimate, an estimate of the right-of-way. So to do this, we took parcel data from NC1map and then basically took the inverse of that data, right? So any area that isn't within a private, withholding is probably public, right? Is probably within the public domain. And so anything within that is probably a state-owned asset. This doesn't account for easements. So to account for easements, we also took any roads that were in parcels, right, within privately owned land, and then buffered those by 60 feet, and then basically appended that to our inverse parcels layer. And then since that inverse parcels also is for like non-NCDOT maintained roads, right, we took the NCDOT maintained roads layer and then buffered that by 200 feet and then basically clipped all of our data to that, right? So it's attempting to get only the NCDOT right-of-way from those different data sets. This obviously doesn't account for mapping inaccuracies surrounding parcels. It also doesn't account for, hey, potentially the right-of-way is larger than 200 feet. But we thought it provided a good estimate for this project. Something else we did that I think helped was also to provide distances from NCDOT maintained roads, just to kind of have a confidence level of, hey, how close is this to an NCDOT maintained road? And we can kind of estimate then again, hey, is this within the right of way? And then, in the future, we'd like to use that comprehensive right of way layer that DIT is currently working on, but didn't have it for this. For outfalls, so outfalls are interesting under the NPDES permit. So it's not exactly what you would think. It's not an outlet like you would think. You would think it's just the outfalls, hey, this is where the pipe stops, this is where the drainage is occurring, right? But under the NPDES permit, an outfall is defined as the confluence of that drainage of stormwater and a jurisdictional stream. And the municipalities tended to provide their outlet points, right, that didn't meet the definition of an outfall. So, a need arises to create that outfall data. So on my map here, you can see the red lines are open conveyances, pink are our pipes, and then the white dots are outlets, right? So those were the data pieces that were provided from the municipalities. The yellow dots were manually created. They were, this was just like a little pilot to see, hey, how can we create this outfall data? So essentially, it's snapped over to the jurisdictional stream from the outlet point, right? Based on that conveyance, those red lines from the outlet, hey, where does this intersect the jurisdictional stream? So yeah, we aren't tackling this in the next phase of this project, but we want to do some investigation into, hey, how do we generate this outfall data? So yeah. And then also we have the question of which hydrography data set do we use for this project? How do we get our jurisdictional streams? So NC OneMap has a 24K streams layer, but it's kind of more general hydrography, kind of more major hydrography than what we were looking for this project, right? We didn't want to miss a perennial flowing stream in this process. So we decided to go with Atlas Hydrography. That's a data set that is made in partner with NCDEQ, NCDOT, and some other consulting firms. So that provides great data on perennial streams, but it is elevation derived. So as you can see on this map, we've got some that cross the roads, right? Just based on the pure elevation, it's going to model that it's crossing the road, the blue streams. And so this causes a potential data problem, especially in urban areas where we are mapping this data to get those jurisdictional streams. But I think there could be a pretty cool chance for like a data handshake between this team generating all that stormwater data and Atlas Hydrography, right? Maybe we can provide those connections from the stormwater data to the Atlas Hydrography team, right? And then they can like burn that in to their DEMs and get that flow through pipes as opposed to flowing over roads. Another thing with outfalls is the distinction between major and minor. So a major outfall is defined as if it's in a non-industrial zoning area, it's got an inner diameter of 36 inches or more, or it drains more than 50 acres. In industrial zoning areas, it's got like fewer requirements, right? So inner diameter of 12 inches or greater, or the areas that drain more than 2 acres. And then minor would be all other outfalls. So to fully resolve this process, we'll need to evaluate existing data and potentially create new data. So we have pipe size from most municipalities and can acquire zoning data, right? But we don't have those drainage area estimates, right, for the pipes to know, hey, how much area does that drain? And this is a potential future task. How do we create drainage areas for each one of these pipes? I did create, for a separate project, a drainage areas toolbox that you can use to essentially create a drainage area for each pipe. Like, how much area does this pipe drain? So I'll talk about more. Talk more on that in a second. So what's next for this project? We're starting phase 2 soon, so I'm going to talk about some of the phase 2 goals and then some of the potential future tasks that could come out of this project. So since we saw our problem with outfalls, phase 2 actually expands on the data sources that we're using within this combined stormwater database. One of these is a current project that's going on at NCDOT to gather bridge outfall data. So along with aggregating those stormwater, so we'll also look at a QA/QC process for those bridge outfalls collected under the separate NCDOT project, and then combine those within our data set, right, for the next phase. That should hopefully give us some more outfall data to be used in our stormwater database. And then next, we're going to conduct a pilot desktop review of the data from the MS4s. You know, we noticed during the first phase that there was a difference in quality and quantity of data from municipalities. So we'll look for any gaps, any potential gaps in data to identify areas where additional stormwater mapping may be needed. We'll also identify any interconnections between the NCDOT system and the Phase 1 MS4 system. And then another thing that I already talked about was those drainage areas, right? This is in phase 2, but again, a potential task is creating drainage areas for each of those pipes to understand, hey, how much area does this pipe drain, and help us with the distinction between major and minor outfalls. And then again, as I hinted at earlier, I think there's a really good potential for data handshakes here between specifically the Atlas Hydrography team and the Stormwater Data Project, right? If we can provide those stormwater assets and pipes, then they can make better models, right? And then if they have better models, better DEMs that burn in those data points, then maybe we can create better drainage areas from those DEMs. So I think it's a good potential handshake between those two groups to make the data better. But yeah, that is all I got. Any questions for me? Yes, sir? Yes. No, it's not right now. It's mainly used for the DOT, but it is using DEMs from the Atlas Hydrography project. But it's really just standard tools that kind of pipes everything into one flow, right? You've got your flow accumulation kind of all mapped out. So it can take an input point or multiple input points and then create a drainage area. But it's using mostly like the spatial toolbox or the hydrology spatial toolbox from Esri. Yes?
If you have gaps in the local data for your pipes and culverts and actually need to create new pipes, culverts, do you digitize those in the field or do you come back to the office and do it?
We haven't done any of that yet, but this next phase is going to identify areas where those gaps exist. I would think we would probably then try to tap the municipality, say, hey, there's a data gap here for you, right? Do you need to go out and send somebody out? Maybe a field map, maybe it's like as-built. Maybe they already have that information and they haven't loaded it in yet. So that's what I would say.
Is there going to be a handshake back to the municipalities for the data?
Yes. We've been, and I kind of glazed over that. So then that phase 1, we were talking to the municipalities, right, to get their data. And we definitely want to do a handshake back. I think we've got some more meetings planned for this year, or maybe next year. This year? Okay. I'm getting a thumbs up in the back. Yes?
So I think that some of the municipalities, part of the reason besides the full requirement, if they map their stormwater infrastructure, they need to know who's going to maintain it. So there's usually
Yeah, it was kind of hit or miss with that, right? They did have an ownership field, but it wasn't always aligned with what was in the right of way, right? And I think that would be another good potential handshake again between us and the municipality to say, hey, we see that this is in the NCDOT right of way, potentially, right? Hey, can we give this data back to you and you can improve your data set? You don't need to maintain this anymore, right? It's an NCDOT asset. Yes, sir.
So there's like obviously a lot of different data pieces that are going into this.
Yeah.
Both like from your end and from like DOT and the client end, how do you make those calls about like what's the authoritative data source, what's the best data source, what's your like acceptable margin there? Like when you mentioned missing assets within a municipal data set, like what's the balance that you guys are considering there? Obviously there's not a right answer, but
Right.
like how are you all thinking?
Yeah, that is a tough conversation, right? Like how, what is authoritative? We talked about what is the definition of authoritative a lot of the time, right? And I think we kind of have to take the municipality data as the authoritative source for their data sets, right? They're out there constantly. They're drawing in as-built. They're going out in the field and collecting that data. So we kind of thought of that as like the, authoritative source for each municipality, right? We aggregated everything together and didn't really delete anything, but I think in the next QA/QC portion of this data review, we'll look at that and say, hey, there's two pipes that are parallel here, maybe, right? Which one's right? And mark those and go back to them. So.